For the next 3 days in this course, we're going to look at 3 different methods of solving linear equations. This is when you have 2 different lines, and we're going to look at how 2 different lines could interact with each other. So solving a linear system means finding the point at which 2 lines intersect. A linear system can intersect in 3 ways. So we'll draw 3 different Cartesian planes. All right, one way that 2 lines could intersect is the line could go like this, one line like this, and another line like that, and they could intersect at one point. Okay, so 2 lines, 2 random lines could intersect at one point in one place and time. Another way that 2 lines could intersect, this one's quite unique, is that it could be that they are infinitely intersecting. So the 2 lines are exactly right on top of each other. In fact, they're the exact same line. And this would have an infinite number of points of intersection. Because there's an intersection point here and here and here and here and here, and it just keeps going on and on. All right, now my wording's a little confusing because the last one's a bit of a lie. The last way they could intersect is that they simply did not intersect, and that would be if you had 2 lines that were parallel. Okay, so if they were parallel, then there would be no intersection point. Okay, so we have our 3 ways that they could intersect, and one of which really is not intersecting. So one point could be an infinite number of points of intersection, or they simply could be 2 parallel lines that will never meet. Adding a little note onto each of these, or onto some of these, this would have the same slope. This would be key to this situation. They have the exact same slope, but they would have different y-intercepts. This would be the same equation right here. It'd be 2 equal same equations, like y equals 2x plus 1 and y equals 2x plus 1. Obviously, those 2 are the same line, and so they always intersect. They're the same. Okay, we're primarily going to focus on this situation here where we have 1 point of intersection. In this unit, we will learn 3 ways to solve a linear system. One is solving by graphing, the second is solving by substitution, and the third is solving by elimination. So solving by graphing, method number 1. Steps, we're going to graph the 2 linear systems. I use this step very broadly because it assumes that you know how to graph 2 lines. Step number 2, state the point of intersection, POI, by stating the POI is, and then we state the X and the Y point right there, okay? So let's look at this equation here. Here we have equation number 1, okay? Here the slope is -6, and we would assume that's over 1. Correctly, we would assume that. And the y-intercept is -4. So on the graph below, we go, here we go, -4 is my y-intercept. And then I'm supposed to go down 1, 2, 3, 4, 5, 6, and over 1. Well, that's a real pain because it's not on the graph. So instead, I'm going to say, well, that's the same as 6 over -1. Remember, -6 over 1 would be just the same as 6 over -1. What's different about this is now we're going 6 up, and we're going 1 to the left. Okay? So 6 up, 1, 2, 3, 4, 5, 6, and 1 to the left. There we go. Okay, and we draw a line going through those 2 points. It'll be really important. I can't do this on the iPad. It'll be really important that you use a ruler to make sure these lines line up. Okay, equation number 2. Let's work with this right here. Well, this is not in slope-intercept form, so what we're going to do is add 2x to both sides. And that would give us y equals, well, we have 2x's, and then this number 4 is all by itself, so that's the y-intercept, 2x plus 4. So now we know our y-intercept is 4, and our slope is 2 over 1. So we put a point at the y-intercept at 4, and then we do our slope of 2 over 1, so that's up 2, 1, 2 over 1. Again, it's off the graph, so what's the same as doing positive 2 over positive 1? Well, that's negative 2 over negative 1. So we'd go down 2 over 1 to the left, and there we go. So it's going to go down. Again, please use a ruler, even though I can't seem to do that. All right, we've graphed both lines. Our step number 2 here is to state the POI. Simply by saying the POI is, and where do the two lines intersect? Well, they intersect at -1 and +2 right here. That's where they intersect. So we write the POI is -1, 2, and that's your conclusion every time. You either say the POI is, you state it, or sometimes we have these unique situations where we would say there's an infinite number of points of intersection, okay, or we would say there is no intersection point, okay? So it's those three options. Again, I said primarily we'll focus on when they intersect one time. All right, let's look at this equation here. It's in y equals mx plus b form, so we already know that m is -2 over 3. I'll assign the negative value to the top there. And then my b value is -2. So my y-intercept is -2. Slope of my line is -2 over 3, so down 2 over 3. Okay? And it's going to continue in that direction, so draw a straight line. By the way, if you know it goes down 2 over 3, you also know, whoops, that it will go over 3 up 2 up here too. It's going to continue in that direction. It's just going to continue in that -2/3 slope. All right. Next line. Y equals -4. Okay, this one's a little odd. Remember, we do that little rule where we say, okay, y equals -4. So obviously it's going to cross the y-intercept at -4 because y is -4. And y equals -4 is simply a horizontal line that goes through at -4 because this is the place where y is always -4. All right, final step. See the point of intersection? It's right there. So we write the POI is, and the POI is 3, -4. There we go. Point of intersection. So this is method number 1. It's solving by graphing.